Hello. We've done with the laws of indices and we've done how to apply the laws of indices. So today you can see on our board we have what they call the powers in simple linear equation, meaning that we're working with indices which is involving powers in simple linear equations. Okay, now what's a simple linear equation? What's a linear equation? A linear equation is an equation or any equation with one unknown. So when you have just only one unknown, it is a linear equation. Now from the term equation, from that word equation means that there's an equal to sign. Whenever I hear the word equation, means there is an equal to sign. So let me give an example of a very basic simple linear equation. 2x is equal to 4. Now this is an equation because there's an equal to sign, and then it is linear because of there's only one unknown. Is that okay? So it's linear because there's only one unknown, and it's also have an equal sign, therefore it makes it an equation. If there was no equal to sign, let's say if it was just only 2x, then this is an expression. An expression is a mathematical statement that has no equality sign. So what we were doing before was just simplifying expressions, but today we're now going into working with equations. There we have to find what is the value of that x or whatever value they give you to find in the equation. Okay, so let's begin. I think I've spoken well enough, and let's take down all these and start writing down something. Now, in solving a simple linear equation, there are two things I would like you to consider or to take note of. Sometimes the unknown might be the power, or the unknown will just be the base. Okay, so when the unknown is a power, make sure, now please pay attention, when your unknown is a power, make sure you write everything in a singular base. And when your base is the unknown, so when your unknown is a power, then make sure you write everything in a singular base. And when your base is the unknown, then please try to eliminate the power of, then just try, okay, let me know why I shouldn't use the word try, sorry. So what should you do? You should take away, that's eliminates the power. Okay, now I will show you what I mean by everything I've just been writing down here. Please forget about this jargon. Let's go to the other side of the board and then try to take a question. Now I'll take a question with just with where the unknown is a power. So let's take a question where the unknown is a power, and you see how we solve it. So I have this one, very easy question, very simple, easy question. We have this 3 raised to the power of 2x is equal to 27, and we are asked to find x. Now remember, x is a power, right? And therefore I told you that if your unknown is a power, then what do? Write everything in a what? Singular base. So you look at this and check, is there a singular base I can find here? Yes. What is the base? The base here is 3, and the base here, so I can write 27 in the base of 3. Is that not so? Yes, because remember in our previous class I showed you that 3 raised to the power of 3 is equal to what? 27. Is that okay? So I can take this off and I'll continue. So therefore, what are you seeing we're doing here? We're writing everything here now will be in singular base. So here is 3 raised to the power of 2x and 3 raised to the power of what? 3. Is that okay? Very good and fine. Now what's then the next thing you do? We can then take away the bases. Once the bases are now singular, as they're now the same bases everywhere, okay, I think I should change that word from singular base to common base. So let me use the word, I think common suffices well to write with, not singular, common base. Okay, because when you say common, it means that it is found in both sides. So now that I can find a common base, what should I do? I eliminate the common base out. So I cancel this base, and then I work with only the index. So the index becomes my new base. Okay, so now normally this cancelling is not really done, so you just forget about the bases and then you start working with the powers. So I work with my powers, it becomes 2x is equal to what? 3. And then knowing how to solve this, you can divide through by 2, divide through by 2, and x is equal to what? 3 over 2. And that's the answer. Quite easy, right? Let's do one with a common base. Now I'm just taking very easy questions because I don't want to start solving anything tough right now. Let's first start with easy stuff. So common base. When our base is common. Okay, I'm looking for a question where I have a common base here. Let's see. I think I have one question here with me. Okay, yes, I have one. Now look at this question here. Okay, let me take my screen a little bit this way. Now this is a question here. We have 2. Okay, let me change. I want to use a different color. 2 square root x is equal to 4. Now remember I told you that once this 2 is not attached to your square root, it's like saying 2 multiplying the square root of x, so it is different. So now let's continue. Now we are told to find the x. Now notice something. I can write this square root in the index form. Is that not so? Yes. But before I do that, let me divide through by what? 2. I can divide through by 2, and I have the square root of x is equal to 2, right? 4 divided by 2 is 2. Now I can write this square root of x in the index form. Writing it in the index form, square roots in index form is like saying x raised to power 1 over 2. Is that not so? Everything is equal to 2. Then what do I do next? Remember I told you, I said that when you have a base, I said do what? Eliminate the power. Sorry, I'm cancelling that. I said eliminate the power. So notice something here. We have the power here, right? This is the power. Now we need to eliminate this power. But to eliminate this power, I have to, in mathematics, you don't just take things off like that. You have to mathematically transfer it, that's manipulate it so that it can balance equations, so that the equation can be balanced. You don't chemistry where you do balancing of equation. Now whatever you do in the reaction, it must also affect the reactants. Do you remember that? Now that's exactly what we'll be doing here. We'll do that. Whatever we do in the reaction has to also affect the reactants. So now if I was to take away this half, that's this raised power 1 over 2, what will I multiply to take away raised power 1 over 2? Imagine that. So if I have 1 over 2, what do I do to take it away? Use the reciprocal. I remember you've been told they call reciprocal. Reciprocal of every number is that number that when you multiply it, you get back the identity. So if I say 1 over 2, the reciprocal is what? 2 over 1. Because when I say 2, we cancel out 2 here, and 1 cancel out 1 here, then I have the identity. What's the identity? 1, right? So I can just say 1 over 2 multiplied by 2 will give me 1. So therefore, whatever I do in the left hand side, I must also do in the what? In the right hand side. Is that okay? So let's do that. So I say x 1 over 2 multiplying 2 is equal to 2 raised to power 2, right? So because I multiplied raised to power 2 here, I also have to multiply raised to power 2 here. So therefore I can now cancel out. So 2 cancel out 2, and then we have x standing alone, because x raised to power 1 is still x, and is equal to 2 raised to power 2 is what? 4. So our final answer is what? 4. Now I believe we understand this. So whenever we have an unknown, whenever we have the unknown as the power, what do? You try to, you make it in a common base. When you have a base, sorry, it's not meant to be common base. When you have a base, you try to, or when you have a base, this is not, when you have the unknown as a base. So when you have the unknown as a base, then what do? You eliminate the power, like what we did here. Okay, so the next videos will be taking more complex questions to solve. This was just an introductory into the class, and then next videos will be taking more complex questions. So click on the next video.